Makerere is the premier university in the country and in the region, and in this regard, Makerere has repositioned herself as a research-driven university. This has meant that it had to develop and nurture its own research and innovation policy, which has called for enormous investment in terms of resources for research infrastructure development and capacity building. To this end, you find that the research at Makerere has been basically supported from three main streams: from government and its development partners and the internally generated resources. From the development partners, we are proud of the Royal Government of Sweden for supporting Makerere to undertake its mandate and execute its research agenda to date. We have received about 495 million SEK, equivalent to about $71 million, to support research. And this money has gone to building research infrastructure and environment and building the research capacity of the staff of Makerere and the partner institutions. This particular phase 3 of the research support will end in June 2015. But thereafter, we've been invited to submit a proposal for the successor SIDA program that will last 5 years, 2015 to 2020. And in that particular proposal, we intend to move research to the next level, that is with emphasis on research uptake, whereby we intend to move from basic research to commercialization of the research output, and this will involve Makerere and its partner universities to build the synergies to see that they prepare the development challenges through evidence-based research in this country. We are very grateful to the people and the Royal Government of Sweden for the enormous support they have given to Makerere to support the research profile and agenda. As you are aware, this fund has been used to strengthen the research management and coordination, improve the research and publication culture at Makerere, and above all, it has improved the funding levels for research and innovation. It has also helped us to, of course, to build an enabling environment for the quality research that is currently going on at Makerere. For this, we are always and we shall always forever be indebted to the people of Sweden.
The title of the sub-program, Science Sub-Program in the SIDA Phase 3 Bilateral, is Enhancing Capacity in Basic Science Research for Sustainable Development. The sub-program is coordinated by Professor J.Y.T. Mugisha, who happens to be the principal of the College of Natural Sciences. I am the deputy principal of the College of Natural Sciences, and I work closely with Professor Mugisha in running this sub-program. On the Swedish side, Professor Peter Sundin is the sub-program coordinator. This science sub-program is coordinated by the International Science Program based at Uppsala University in Sweden. Science participated in the development of the proposal, SIDA Phase 3 proposal, in 2009. Our proposal went through and science came on board in 2010, January 2010, when this current phase was beginning. SIDA supported 5 projects in the current phase. And also, in addition to that, SIDA supported 2 students for PhD training outside the original support of the 5 projects in the Science Hub program. In total, we have 7 PhD students. We are building capacity in science, and all these 7 PhD students are progressing well. Out of the 7 PhD students, 2 are submitting their PhD thesis for examination purposes in October 2014. The other PhD students are also progressing well, and the very last one to submit, we expect this to happen maybe around May, June next year, within the prolongation period.
The SIDA Green Chemistry Project is headed by Professor Henry Sikalo. We have a collaborator, Professor Ulla Wendt from Lund University in Sweden. Initially, this project was being funded by ISP and EPICS, of course getting funds from SIDA. And the work of the project is focused on two areas. The first area is to do with the development of catalysts for different industrial processes, including oxidation using green oxidants, carbon-carbon coupling reactions, and carbon dioxide utilization to form useful chemicals. The second part of the project is focused on interactions involving nitrogen derivatives with metal species and their applications in quantification of some environmental derivatives, including the sulfide and the sulfide. In addition, some of these species can be utilized in medicine, for example, in the treatment of cancer. In the second part of the project, which is to do with interactions involving the nitrosyl species, we have a PhD student, Solomon Iga, who is basically involved in this kind of work.
My project is mainly based on the determination of sulfur derivatives in the environment. It's a project that I started on during my MSc study, which was also funded by SIDA, though through EPICS, and then I carried it forward to my PhD. We look at sulfur derivatives in the environment. Sulfur derivatives like sulfide or sulfide are toxic to the environment, and so they should be determined to know their amounts. The sulfide in particular is also used it's claimed that the sulfide is responsible for the therapeutic potential that people normally benefit from hot spring waters. However, in most of the times, we do not know the amount of sulfide that is in hot spring waters. So in this work, I mainly use coordination compounds to react with sulfur derivatives. That reaction normally yields highly colored species, which can be detected by the eye. So in the first place, the eye can detect the presence of this species. Then after, the species are put into an instrument that can measure the intensity of the color, and by so doing, it determines the concentration of these compounds. Now, in addition, the coordination compounds are used for determining these sulfur derivatives also have importance. They have been known to treat cancer in human beings. So in this work, we kill two birds with one stone. We determine sulfur derivatives and also create new compounds that can treat cancer in human beings. In my work, I synthesize new compounds, characterize them, and then react them with sulfur derivatives in the environment. The synthesis and characterization is done in Sweden, where I do laboratory synthesis and then characterize the species with various instruments, and the determination in the environment is done in Uganda. The challenges I have encountered in this work were mainly two. The first is the difference in technology between our country and Sweden. In Sweden, I can do my work very well using all the facilities, the high-tech labs that are there. But when I come to Uganda, it's always very hard to continue my work, since my work is basically laboratory work. There is nothing more than that. So we have been trying to build capacity here by buying equipment and trying to upgrade our labs so that we try and fit the standards in Sweden and try and be able to do some work here. The other big challenge I faced is sickness. I fell sick and couldn't continue with my work at the pace that I really wanted, so it lagged for some time, but now things are better, and I'm going to continue thanks to the prolongation program by SIDA to help me progress with my work. I've benefited a lot from SIDA. I got my MSc Because of SIDA funding, I got publications because out of this work, I've made very many good friends out in Sweden. I've been exposed to high-tech instruments like a 500 megahertz NMR. I can use it very well. I can use an XRD, that's a single crystal diffractometer, to look at crystals and determine the structure of the compound. I've also been exposed to a squid, which measures paramagnetism of complexes, and many other equipments.
The project that we have been doing under SIDA started in 1999. At that time, our concern was the chemicals which are in water, which are in fish, and in foods, but especially in water and fish of Lake Victoria. We also had to train people to be able to analyze and get those chemicals and find out whether they do exist in fish and in water. Over the course of time, we have trained 10 master's students and 1 PhD student, and the second PhD is almost complete. We have participated at conferences and presented over 20 papers, thus interacting with the public and informing them of the dangers of chemicals so that they can help us in mitigating the problems. We have also published over 8 papers in international peer-reviewed journals, and a good number have been written and submitted but not yet published. Over the course of time, we trained a number of technicians in order to make this project sustainable so that they can continue to train students who come to this lab. At the moment, we have 2 students who are being trained by the technicians. The 2010-2014 bilateral project was only sponsoring 1 PhD student. That PhD student has not yet graduated, but he has published 2 papers in international journals. He has drafted 2 papers for publication, and he has got a PhD thesis which is completing. Over the course of time, we have gathered equipment such as gas chromatograph upstairs. We have used the research facilities which have gathered to train people from other countries. For instance, we have hosted students from Kenya, we have hosted students from Tanzania, and we did organize summer schools twice, at which we trained over 20 students from Tanzania, Sudan, Zambia, and Sudan, including Uganda. In this way, we have impacted the academic staff at various universities, but at the same time, through our presentations at workshops and international conferences, we have interacted with the public and made them conscious of the chemicals and their effects within the environment. We are continuing to do research, and we hope that we will get more sponsorship to continue. The current challenge is that this project has not been sponsored for the next phase of the bilateral project. Nevertheless, we hope that we'll find some other funder to continue funding us so that we can train more people in this area of research.
Kasese district has been regarded as the most polluted district in the country because of mining, whereby the waste products were deposited in the surrounding of the mining areas, and this as a consequence of floods coming from the mountains. These have been washed downslope into Queen Elizabeth National Park. In addition to that, there was a deposit of pyrite materials close to the road leading to Mbarara from Kilembe, and from Kasese. And the waste materials from this deposit was spread into the park, and it destroyed shallow-rooted plants. And when I observed this as a scientist, during the times that I used to take students out in the field, I found that I could do something. And I wrote a project therefore, which we sold to SIDA, and it was supported. And when it was supported, I decided to include into the team a PhD student. And most of the research that we did was for the purpose of attempting to restore the degraded habitat, which included a total of 150 hectares within Queen National Park and extending over a distance of 11 kilometers down to Lake George. A lot of results that were produced from this research emanated or resulted in the production of 4 published papers. Now, out of that, outside interests were generated, because I remember the former executive director of NEMA visited our study site and was quite impressed by the work that was done, that our methods could be applied elsewhere to restore polluted and degraded habitats in the country. Then I must say, finally, my student is about to finish writing up his thesis, and I would be very happy if he can submit in the next 2 weeks or so, because that's the time we have estimated for him to complete his work.
My work has been about developing new technologies that can be used in the restoration of heavy metal degraded areas. The conventional techniques are too expensive, and therefore there is a need to come up with the technologies that are cheaper using local materials. So in this study, we had to use local growing trees and very abundant amendment materials like compost and limestone. We collected the data and analyzed it, and I have managed to publish 4 papers, and the 5th one will be out soon. The thesis writing is nearing completion and will be submitted mid-October. Being a multidisciplinary study, I have managed to acquire skills in different areas, like for example the use of the atomic absorption spectrophotometer, use of new gadgets like the microplate reader, which is used to determine bacterial functional diversity, and I've also managed to learn how to use new statistical packages like R, and doing some bit of modeling, which is well known to mathematicians other than the botanists. The funding was excellent in that I managed to overcome all the financial problems, and the challenges that I faced were majorly in the field, issues to do with attack from wild animals that constantly attacked my study plots, vandalizing them to the level that I sometimes had to go back to square one. Also, some people were interested in the trees that I was studying on, and they were cutting them down.
I'm looking at plants with medicinal and nutritional values that are used in the management of HIV/AIDS opportunistic infections in the western part of Uganda. The main aim of this study was to document these plants that are used by the local communities, and also to validate them in terms of their bioactivity profiles, to look at their antimicrobial activities, and also the antifungal, both antifungal and antibacterial, and then also to find out if they have any nutritive values in terms of antioxidants and also the mineral elements. So I selected a few plants. I took them to the lab for analysis. I looked at their antimicrobial activities. Then I also tested some of the plants for their toxicity effects, because most of these plants are taken in orally, and also the antifungal activities. So I found that actually some of these plants are very potent in terms of treating fungal infections that are very common in HIV patients, like Candida albicans and Cryptococcus neoformans. There are some plants that prove to be very potent, and I believe that if these plants can be studied, they are very good lead agents for these compounds, and they can be used in making antibiotic drugs. So I also checked for the antioxidants. Some of them also proved to be effective, have got high antioxidant capacities, and also they have some minerals that are also important, as in helping in the immunity boosting of HIV patients. Some of the achievements that I managed to record a lot of plants that are really trusted and used by the local communities. And I hope that if these plants can be domesticated, probably they could be of use to the general public. I have achieved so much in areas of microbiology, toxicity, toxicology, or chromatography, because I've learned new techniques in analyzing plants. And I believe I'm happy that I'm also going to get a PhD degree. I have managed to interact with many people from different academic backgrounds, both locally and internationally. I've interacted with people in Sweden, in Japan, in China, in Nigeria, and all over. From this work, I have managed to publish 4 papers, and I still have 2 manuscripts which are almost ready for submission.
My work is about the quality of raw materials that are used in making fish feeds. I looked at lipid spoilage and how the resultant products affect the growth of fish. I also looked at how we could use the natural antioxidants which are generated from plants to control lipid oxidation. I also looked at how the natural antioxidants affect fish growth and performance. And because mukene, fish meal, which is commonly used in the East African region, experiences lipid oxidation during the process of processing it, I further looked at how it could be replaced. That's for one reason. And also, we are aware that as the population is growing, competition for mukene is growing, its prices have also gone high. We established that mukene undergoes spoilage, particularly when it is treated and salted and stored. With the time, it keeps on depreciating. Our results also interestingly reveal that the natural antioxidants, particularly rosemary, can be used to effectively control lipid oxidation. And in a way, rosemary also can stimulate fish growth compared to feeds that are treated with the artificial synesthetic antioxidants and the seaweed that I got from Iceland. My results are important and can impact the society in many ways. One, the use of natural antioxidants is something which is relatively new, and there is an outcry that the natural antioxidants must come on market because the artificial antioxidants have been found and speculated to be responsible as precursors which are causing cancer. The other issue which I mentioned earlier is that this work is of interest because it shows that we can replace mukene using the manga bean, which are easy to grow in Uganda and other tropical environments, and they are very easy to propagate. But in Uganda currently, they are grown on a low scale and used as human food, but very few people eat it. So this is an avenue that they can be used to replace mukene fish meal, which undergoes oxidation, and people can grow them and make money out of them. Secondly, the freshwater shrimp, which is scientifically called Calidina nilotica, is one of the replacement which has been found to be effective. Its amino acids have been analyzed the proportions which can be used to replace mukene. We have determined them in this study, and the information which has not been available, including that of mukene, the amino acid profile, much as it has been used here in Uganda for a while, it has not been documented. So in this work, it has been brought to record. Probably one would want to know, as a person, what have I achieved? Yes, the reason I went into this was to get a PhD. Very soon, I will be defending my PhD thesis, and that's an achievement to me as a person, but also to the money power of Uganda and Makerere as well, and international anyway, because I in a way, I have now got collaborators elsewhere besides Uganda, in Sweden and Iceland and Norway, all of whom have met me, I have interacted with through this program. Another achievement I have come to appreciate the culture. I've interacted with so many people at the Hola University College in Iceland, at the United Nations University in Iceland, and at the University of Iceland, where I've done much of my work. So cultural differences have been appreciated. That's something which I wouldn't have got if I had not gone into this study. I'm now a fellow, and through this program with the United Nations program, and I do assignment on their behalf at times when I'm given a chance. So all these I've achieved them through this program. One challenge I would say, and I would call it probably a challenge and an opportunity at the same time. At the college where I've been settled with my professors at Hola University College, I've been the only black man around. Of course, it is challenging a bit, but I've overcome it by socializing with people, by finding my level within the system, and I've achieved that. I would like to conclude by thanking the United Nations University Fisheries Training Program for having partly funded my work, as well as the SIDA program, which we have also funded part of this PhD program. SIDA in particular funded the work which I've done in Uganda, which included the analysis of lipid oxidation in mukene. That was a very expensive study because I had to carry on several analyses in the labs here. I had to do field work. I had to collect a lot of information using SIDA money. Thank you so much.
We are working on the hydrodynamics of a tropical equatorial lake Victoria because of its fundamental importances both to science and to the local community. Why hydrodynamics, and how important will it be? By looking at how the lake flows and the motions within the lake, this will help hydrologists to analyze the underground flow within the lake, the hydrodynamics of the lake, the motion of the water currents, will also help us study the pollution and contaminant flow within the lake body. This again will help scientists and scholars about the stratification within water bodies to analyze and understand when Lake Victoria is fully mixed and when it has layers. Because the research goes deep into looking at how also climate change affects the water levels within the lake, this will help the governments and the local community to predict and know when the water levels within the lake will be high or low. We have managed to write 3 manuscripts. 2 are ongoing. I've attended conferences and workshops in many countries because of this sponsorship and research. I've learned and I've used a new software called CoNAS to simulate our models. Among the challenges, it's data accessibility, because the the normal way, the natural way of looking at the lake would have been looking at it in totality, but because of data problems within the 3 countries, it has still been a very big challenge. We have managed to talk to many companies, mostly in Kenya, NGOs, and they have been helpful in giving us some of the data which we have been using to simulate the previous results. Such non-organizations include LAVEMP, Lake Victoria Basin Commission, they include the Water Resource Management Authority, our Ministry of Water in Kampala, and KEFRI, the Kenya Fisheries Institute, which provided us with a bathymetry data map.
I extend, on behalf of science, our sincere thanks to the government of Sweden. We are using taxpayers' money of the Swedish people. Difficult to believe, but it is true. They are using their taxpayers' money to support Makerere, and in turn 4% has come to science. We also extend our sincere thanks to the government of Uganda. You know, SIDA, the current SIDA, operates in very few countries. But why was Uganda chosen? I think we give credit to our government. So thanks our government for providing conducive atmosphere to attract this kind of support. We should also be grateful to the university management under the leadership of Professor John Dumba Sentamu for the able leadership, and it's because of this good leadership that SIDA is supporting Makerere. We also extend our thanks to Professor Katunguka, who was the coordinator of this project when we joined. Science joined in 2010, and Professor Katunguka was the director of the graduate school then, and he was the coordinator of the SIDA project. Professor Buyinza has done a lot in the short time he has been in the office. Please let him continue with that kind of energy. We are so happy about his support to the SIDA project and more so to science.
This support has been monumental and critical to the realization of our core functions of teaching, learning, research and innovations, as well as the partnerships and the networking. A number of our staff have received PhD training through the SIDA funding. I'm happy to report that since 2000, when our cooperation began, over 150 academic staff have completed their PhD studies, and over 30 have completed their master's studies. So we do thank you. The support has greatly improved the research culture of our university. Publications have greatly increased, but most important, SIDA funding has greatly contributed to the visibility of our university in terms of ranking. As you are aware, Makerere University is the second on the continent in terms of research output and publication. The SIDA support has also contributed to the enhancement of the centers of excellency in waste management, ecosystems research, and renewable energy research, among others. With support from SIDA and the other development partners, we have been able to improve library services. The library provides
up-to-date information, not only to Makerere University, but also to the entire country. Internet services have greatly improved throughout the whole university. But through SIDA's support, Makerere University has been able to establish strong collaborations with the leading universities, including those from Sweden. We have learned best practices from these universities, and they have also benefited from joint supervision, which has ensured high quality of our students. As we are aware, the SIDA Phase 3 will come to an end in July 2015. Makerere University has already submitted a full proposal for the consideration for the possible continued support beyond 2015. We'd like to assure you, Your Excellency, that the money will be put to good use. We shall always endeavor to observe the guidelines governing our cooperation. Let me also assure you, Your Excellency, that we shall correct any shortcomings on our part and ensure maximum adherence to the said guidelines. Once again, I welcome you to this review meeting, and I wish you fruitful deliberations in the days ahead. It's now my honor and a privilege to invite His Excellency the Ambassador to give his remarks and thereafter officially open this review meeting. I thank you.
Everybody in this room knows that research is a long-term undertaking. There are no quick fixes in this field. In the rapidly spinning global economy, the lengthy process of research may appear too slow to answer to those everyday problems. However, as recognized by the Swedish government, the significance of research for society is that it expands the options. Research creates new insights and hopefully also answers. It provides solutions. It forges boundaries by constantly posing questions and seeking understandings of upcoming complexities. Subsequently, we must have time to wait for your work to come to fruition, and we must invest in research training. Without graduate training and cultivation of research culture, research environments will not take root. But we also must remember that each research result cannot be only claimed, it must be demonstrated. Your science outcomes must be actively put to use. The utilization of research results is a major concern for the Swedish government. The Embassy is currently procuring a study to identify the interface between the research program and private sector development. We hope that this work will be a stepping stone in increased utilization of research results here in Uganda. We have then gone full circle. Your tremendous work efforts in the south and in the north, in the current agreement and in preparations for the next, are all critically important. Together, you are building Uganda's intellectual environment for analysis and debate for tomorrow's problems identified today, not only here, but in Sweden and as part of the global economy. In conclusion, I would like to wish Makerere University and partners much success with the annual review meeting and the Science Day, of course. This annual review meeting will surely feed into the announced International Science Conference in April next year. The results from the past 5 years of Swedish research collaboration will then be discussed with higher education stakeholders from Uganda and abroad. This international conference, as much as the current agreement period, will hopefully demonstrate a key Swedish government position: that research collaboration is building a long-term commitment beyond aid, a collaboration focused on scientific cooperation on an equal footing between partners. Thank you so much for listening, and good luck with the rest of the deliberations.
I would like to request His Excellency the Ambassador to come and launch this database, which we think is going to help us in tracking the process of graduate training at this university. Thank you.
Well, thank you for this impressive demonstration. You have created a combination of Facebook and LinkedIn, but in a much more serious environment. So my first request, Vice Chancellor, will actually be to request a login and a password so that I can use it for bragging a little bit in my office once it's up running. It's an excellent, of course, opportunity to have more transparency on what we are doing together through a very modern tool. Well, I guess I should launch it by pressing enter or something like that. But as this is a digital tool, I will make a virtual ribbon cut, and I hereby declare the Graduate Research Process Tracking Tool launched. Thank you.